Hi everyone. In this video we're going over some of the solutions for 7.1 practice set working with the Pythagorean theorem. So we're trying to find the length of the missing side. So in number 1 here, the missing side is the hypotenuse, or side C. 8 and 21 are the other two legs, so I can use the Pythagorean theorem, a squared plus b squared equals c squared, to find c. So I'm going to substitute 8 for a and 21 for b. 8 squared is 64, 21 squared is 441. So I'm going to add these two numbers together, and I'm going to get 505. So c squared equals 505. I need to undo this square by square rooting both sides. So the square root of c squared is c, and then the square root of 505 does not simplify. There are no factors that are a perfect square. Okay, let me tell you what I mean by that. Say we got root 8 as our final answer. Well, we could simplify this because 8 is 4 times 2, and the square root of 4 is 2. So that would be 2 root 2. So in this case, we don't get any simplification, so square root of 505 is our answer. Let's take a look at number 4. In this triangle, we know one of the legs, and we know the hypotenuse. So remember, the legs make up the right angle, whereas the hypotenuse always is opposite or across from the right angle. So I'm going to use a squared plus b squared equals c squared again. So I can substitute 12 for a. B I'm looking for. C is 12 root 2. So the difference in this problem is we have a radical for one of the sides. So squaring 12 is easy, that's 144. But squaring 12 root 2, we have to remember that squaring something is the same as multiplying the number by itself. So 12 times 12 is 144, and root 2 times root 2 is root 4, or 2. So the square root of 4 is 2, and 144 times 2 is 288. So now I can subtract 144 to both sides. B squared equals 144, because 288 minus 144 is 144. And then the square root of that is 12. Well, 144 is a perfect square. So when I take the square root of a perfect square, I get a natural number, or whole number. So B is 12. Okay, let's take a look at 6. In this case, again, I need to find the missing side, which in this case is a leg. So I know one leg and the hypotenuse. I'm going to use the Pythagorean theorem again. We're going to see that when we solve for a here, we're going to get the square root of a number that will end up simplifying a little bit more. So let's say 45 squared minus 25 squared is 1,400. So a equals the square root of 1,400. Now, does this number have any factors that are a perfect square? Yes, 100. 100 times 14 is 1,400, and the square root of 100 is 10. So my simplified answer is 10 root 14. 14 doesn't have any perfect square factors in it, so we leave it. Determine if the following sets of numbers are Pythagorean triples. Well, remember, a Pythagorean triple is 3 numbers that satisfies the Pythagorean theorem that are all whole numbers. So no decimals, no fractions. So we're going to put in 12 and 35 for a and b, since they're the smallest of the 3 numbers, and 37 in for c. use my calculator. I get 12 squared plus 35 squared is 1369. Now, if 37 squared is the same, then it worked, and it is. So 12, 35, 37 is a Pythagorean triple. These three numbers, these whole numbers, worked in the Pythagorean theorem. Let's try number 12. 9 and 17 would be the legs. 9 squared plus 17 squared is 370. 18 would have to be C since it's the largest side, and it's 324. No, these are not equal, therefore this is not a Pythagorean triple. Okay, let's try a different problem. Find the area of each triangle below, simplify all radicals. So the area of the triangle is 1/2 base times the height, or area equals 1/2 BH. This 20 I can use as a base. Now the height must be perpendicular to the base. So I have an isosceles triangle. That means the base angles are congruent, and if I draw an altitude here, it will be a perpendicular bisector to the base, which means it cuts the 20 into two tens. So now I have a right triangle with H and 10 being the legs and 16 being the hypotenuse. So find H by using a squared plus b squared equals c squared. So substitute my values. 10 squared plus h squared equals 16 squared. Now I can subtract 10 squared to both sides, so h squared equals 16 squared minus 10 squared. I can go to my calculator here, 156. Now I want to see if I can simplify this. 156 has a factor that is 4. So we can test other factors, perfect square factors, to see when simplifying numbers, but for this one it'll be 4 times 39 gives us 156, and the square root of 4 is 2. So the height is 2 root 39. Now all I have to do is substitute that into my area of a triangle formula. B is 20 and h is 2 root 39. I'm just going to simplify this now. So 1/2 of 20 would be 10, and 10 times 2 root 39 would be 20 root 39 units squared. And that's it. So I hope this makes sense. See you next time.